Now let's continue with the engine oil system components. The engine oil is contained in the oil tank located on the fan case left-hand side. Oil from the tank passes first through an anti-siphon device before entering into the lubrication unit. This anti-siphon device prevents the tank from being drained by the pressure supply pump during engine shutdown. The lubrication unit installed on the accessory gearbox contains a supply pump for bearing and gear lubrication, and 4 scavenge pumps for oil scavenge purposes. The lubrication unit has 2 filters, the main oil supply filter and the backup filter, which is used if the main filter is clogged. The main supply filter is disposable and the backup filter is self-cleanable. The lubrication unit is also equipped with a clogging switch and an oil temperature sensor for indicating. An electrical master chip detector is installed on the lubrication unit on the main return and scavenge line. In case of oil contamination by metal particles, the master chip detector operates a visual pop-out indicator located just above the oil tank. The indicator is red when popped out. In case of pop-out, 4 optional chip detectors have to be installed instead of the scavenge screen plugs for troubleshooting. To maintain engine oil temperature within limits, the scavenge oil is cooled through the main oil fuel heat exchanger and servo fuel heater. For oil pressure monitoring, a low oil pressure switch and an oil pressure transmitter are provided on the engine. They are both located on the left-hand side of the fan case at approximately the 9:30 o'clock position. Here is the low oil pressure switch. And here the oil pressure transmitter. The oil tank, which is in one piece, made of light alloy aluminum casting, has a total capacity of 24 U.S. quarts, or 22.7 liters. An oil quantity transmitter is installed on it for oil quantity measurement. For servicing, 2 ports and a sight gauge are provided. There is also a filler cap for gravity filling with a scupper drain. Do not remove the filler cap immediately after engine operation. Let the oil pressure decrease for a minimum of 5 minutes after engine shutdown. If you open the filler cap before the pressure decreases, hot oil may gush out and could cause severe burns. To drain the oil tank, a drain plug is installed at the bottom of the tank. When the drain plug is removed, an internal check valve prevents the oil from pouring out. Now let's see the engine drain system. The system consists of a drain collector, a drain module, and a drain mast. The drain collector has several cylinders to collect the different fluids. The collected fluids from the drain collector are then drained to the drain mast via the drain module. Here, the drain mast is not yet installed. 4 manual push-to-drain valves are provided to check from which accessory or element the leakage is coming. Before finishing the first part of this video field trip, let us complete the presentation of the components interfacing with the aircraft system. First, concerning fire detection, remember that fire-sensing elements are also installed on the accessory gearbox. Concerning the hydraulic pump installed on the accessory gearbox front face, there is a case drain filter located on the left fan case. This case drain filter has a visual pop-out indicator. Above the case drain filter location, we find the hydraulic low-pressure switch. Finally, the IDG integrated drive generator. Let's see some details. The servicing ports, overflow and pressure filling. The reset ring for manual IDG reconnection purposes. The drain plug for drainage. And for servicing, the location of the oil level sight gauge. This completes the first part of this video field trip.
We continue this video field trip with the presentation of the engine and the nacelle components installed on the wing. The engine periphery is enclosed by cowls, which form the nacelle. The cowling assembly consists of an inlet cowl, fan cowl doors, and thrust reverser C-duct cowl doors. Concerning the engine drains at the bottom of the nacelle, we can see here the frangible drain mast which protrudes through the fan cowl doors into the airstream. On the nacelle left-hand side are located various access panels for servicing and maintenance. On the left fan cowl door is a quick access panel for engine oil tank servicing. On the left thrust reverser C-duct cowl door, there are, on each pivoting door, an access panel for the thrust reverser system actuator, and a lockout fairing plate for flight lockout deactivation. Between the two pivoting doors is the deploy switch access door. And then, on the lower pivoting door, the same elements as shown on the upper pivoting door. Now, let's continue with the engine air intake. On the inlet cowl, there are two identical inlet scoops for the fan compartment ventilation, one at the top and one at the bottom. They are used to ventilate the fan compartment accessories and components. The air intaken is then discharged overboard after ventilation, through an air outlet grid located at the bottom of the right fan cowl door. On the fan cowl door, notice the position of the aerodynamic strake. Other access panels are installed on the nacelle right-hand side for the reverser system and on the right fan cowl door for the start valve handle manual override. This panel is also used as a pressure relief door in case of starter duct burst. Another thing that we can see here is one of the hoisting points of the fan cowl door. When looking at the rear part of the pylon, we can locate the pylon drains. These drains are provided to evacuate and vent overboard air and any residual fluid. To have a better access to the engine, the cowl doors must be opened. The fan cowl doors have been opened, and here the thrust reverser C ducts are being opened using a hand pump. When opened, we can easily see the hooks of 4 tension latches installed along the lower edge of the C duct. These latches maintain the cowls in the closed position, and they are accessible without opening any access panel. Finally, all the cowls are open, showing the silhouette of the engine. Now we can have a look at the engine core to see some details. Fitted on the engine rear part and in continuation of the nacelle, we find the primary nozzle and the center body, which ensure the hot exhaust. Below the C duct cowling assembly, we can see a cowl opening actuator. Each half is fitted with an hydraulic opening actuator installed between the pylon and the C duct. Each actuator is supplied through a hydraulic line routed along the C duct inner barrel and up to a quick disconnect located on the forward frame of the half, where the hand pump hose is connected. During thrust reverser cowl door opening, make sure that the C duct doesn't hit the slat surface when extended. Please read the warning instructions and observe the maintenance manual procedures before opening the thrust reverser cowls. The thrust reverser cowl is then maintained open by means of a hold-open rod. The hold-open rod has 2 brackets on the engine flange, one for the normally open position and the upper for the fully open position. The hold-open rod is secured by safety pins. Note that when the cowl is closed, the hold-open rod is stored on the engine flange brackets. Concerning the fan cowl doors, each door is attached to the pylon by 3 hinges. The fan cowl door is maintained and secured open by 2 hold-open rods. 3 tension hook latches located on the left-hand fan cowl door ensure the latching of the door assembly. Concerning the pylon interfaces with the left-hand cowl door open, we can gain access to the fluid disconnect panel installed on the pylon. In the engine core compartment, we can see the pylon attachment supports where the engine is attached at the forward mount, and at the aft mount. Each thrust reverser cowl door is attached to the pylon by 3 hinges. Near the pyramid support of the forward mount is the nacelle temperature sensor. Only its connector is visible from the left-hand side. On the pyramid support of the forward mount are installed the fire detectors corresponding to the pylon fire detection zone. Let's leave the left-hand side for the moment. The time to go to the right-hand side. On the engine right-hand side with the fan cowl door open, we can locate the IDG and fan electrical connector panel installed on the pylon. This completes the tour of the pylon interfaces. Now, let's have a look at the inlet cowl for some details. On the right-hand side are the connection plugs for the phone jack and the ground. Here is also located an air inlet scoop for the aerodynamic cooling of the ECU. Notice that the ECU cooling air outlet is directly discharged into the fan ventilation compartment. On the right-hand side of the inlet cowl, there are a pressure relief door and an anti-ice discharge vent for nacelle anti-ice purposes. Air bled from the fifth stage of the HP compressor ensures the nose lip assembly heating before being discharged overboard. The airflow pressure is controlled by an anti-ice valve, which is of the electrically operated butterfly type. The anti-ice valve is equipped with a visual position indicator and a manual override. Now, let's continue with the presentation of the thrust reverser system. Each C-duct is designed to contain two pivoting doors and their actuation system. On the forward frame of the right-hand C-duct, we can locate some of these elements, which are the hydraulic control unit, and, for each pivoting door, a hydraulic actuator and latch. We will see each of them in detail later on. On the engine left-hand side, with the fan cowl door open, we can gain access to the thrust reverser electrical junction box installed on the C-duct forward frame upper part. The hydraulic control unit, which is the main component of the thrust reverser system, has two solenoid valves, a pressure switch, and a hydraulic filter with a pop-out indicator, which is not visible here. It is also fitted with a deactivation lever to deactivate the thrust reverser system as a safety procedure for maintenance purposes or in order to dispatch the aircraft with an inoperative thrust reverser. Each pivoting door has a hydraulic latch and a hydraulic actuator. On each pivoting door, a stow switch monitors the door stow position. Only the connector is visible from the forward frame. Installed between two pivoting doors, a dual deploy switch monitors the door deploy position. Only its connector is visible. For maintenance purposes, a pivoting door can be manually opened, but observe carefully the maintenance manual procedures. Safety precautions have to be taken. The thrust reverser system must be deactivated using the hydraulic control unit deactivation lever. To manually operate a pivoting door, each hydraulic latch and actuator is fitted with a manual unlocking device. To manually unlock the latch, an open-ended spanner is inserted into the oblong hole. Using the tool, turn the manual unlocking axis of the mechanism to release the hook. To manually unlock the actuator, which includes an internal claw device, use an open-ended spanner. And turn the manual unlocking square to release the actuator. A white arrow indicates the unlock position. On the forward frame of the C-duct right-hand side, 4 lockout bolts are stored for flight lockout purposes. For the lockout and deactivation procedure, 1 lockout bolt per pivoting door should be installed. Please observe the maintenance manual procedures because the thrust reverser system should be also deactivated through the hydraulic control unit. The lockout bolts are used to fix the pivoting doors to the structure and are installed with their red lock plates instead of the lockout fairings, which are then replaced on the storage bracket. To finish this sequence, have a look inside the C-duct. When looking forward, we can see, near an actuator, a hydraulic latch hook housing. And the inner panels of the pivoting doors. This completes this video field trip.